John, tell us about your company.
Okay, cool. So I left my previous company, Mass and Space Systems, back in July of 2010 to start Altius Space Machines. This company, we're currently established in Louisville, Colorado, and the focus we have is basically trying to look a little bit past where the industry is currently looking at some of the key spacefaring technologies that you need that, I guess you could say the hunch is that some of these technologies can be commercialized today. Specifically, right now we're working on a rendezvous and docking technology, for instance. It's a bit past where the suborbital companies are focused, but it's going to be something that's going to be key for enabling reusable orbital transportation when that becomes available. And I guess for a long time the industry has kind of taken a sequential approach to things. The idea that first you build suborbital vehicles, evolve them up to orbital vehicles, and you start working on on-orbit issues. And the realization I had is, because we already do have industry and applications going on in space, that this is a problem that you don't have to address purely sequentially. You can actually attack it from both ends and the middle at the same time. And so what we're trying to do is take some of these areas that I think are underserved right now or not being focused on very much by the alt space community, and trying to take these technologies, put them on the shelf in products that are servicing existing markets, but that can help enable future markets as the industry evolves.
What are some of the products that you're working on, or some of the technologies?
Okay, so when we started this, we looked at a range of technologies that we thought were good possibilities, and did a little work on each to kind of see which one we could get the most traction with. We've been looking at things like reusable thermal protection systems, micro-return vehicles, rendezvous and docking, air launch, nanosat launch vehicle technologies. The one that we actually got traction with was, surprisingly enough, the rendezvous and docking technology. And that's what's basically becoming our core initial product. My intention with Altius Space Machines is, to develop various product lines that they're all interrelated and support each other on a systems level. But our initial focus, like at least for the next 2 or 3 years, year to 3, depending on how long it takes to get it up and running, is going to be solely on this rendezvous and docking technology that we have. And then as opportunities arise, and once things have gotten to a point where that can run by itself as a product line, maybe we'll then start bringing on additional product lines when it's appropriate. But so for this rendezvous and docking technology, so this is a fairly important issue. All the rendezvous and docking technologies we have today trace back to the initial developments during the Apollo program. They very early in the program they selected the lunar orbit rendezvous mission mode, where they're going to be doing a rendezvous and docking event around the moon in order to lower the size of launch vehicle they needed in order to perform the mission. And at the time they selected it, this thing was at a technology readiness level of 2 or maybe 3. I mean, people thought of some ideas about how to do rendezvous and docking, but they hadn't even built ground test units yet at the time they decided that they're going to go for this mission mode. So, while on the one hand it shows a lot of showed a lot of initiative on NASA's part to take that sort of a risk, it also led to premature lock-in. If you read some of the notes of the people at the time, they admitted that we're making these decisions based on gut feel, intuition, and impartial data, or incomplete data. And the problem is as things have matured, while the rendezvous and docking approaches that are used today work, they're sufficiently dangerous, difficult, expensive, etc., that it really discourages the kind of high flight rate environment that's going to be necessary to see a real thriving commercial space industry. For instance, we've heard here at Space Access, several people have brought up, there's a magic number that most people talk about of 50 flights per year to justify a given, reusable transportation system. And, it'll vary from system to system, but the problem is if you want an actual industry, not just a fluke, not just a point solution, you need competitors. And each of them need to have healthy businesses at the same time, which means you really quickly get into a situation that the end state we want to see is we want to see hundreds or thousands of flights per year. And most of those flights are going to destinations. Most of those are going to stations or depots or other things like that, where they have to make a connection between two spacecraft. And right now, NASA is reasonably terrified of the idea of having 12 rendezvous and docking events, or even 6 rendezvous and docking events with the EELV-based lunar architecture. So what we were trying to do is, okay, with 50 years of hindsight, is there a better way of doing this? Is there a better way of doing rendezvous and docking that can take some of the risk out of it, take some of the hassle out of it, and enable the kind of high flight rates that you need in order to, in order to close the business cases for these reusable transportation systems? So what we came up with was a combination of 2 ideas I'd stumbled on. There's one technology called electrostatic adhesion. It's kind of like when you rub a balloon on your hair and stick it to the wall. You can actually make a system of, a compliant pad with electrodes in it that when you charge those electrodes and conform it around a surface, it'll actually adhere to that surface, regardless of what the material is. Metal, glass, wood, brick, grease-covered concrete, talc-covered glass, you name it. A company out in California, SRI International, that we're currently partnering with on this, they came up with the technology a couple of years ago. And they've been developing it under DARPA contracts for like wall climbing robots, for surveillance, all sorts of different consumer applications. Like, imagine having something like a kitchen magnet that you could stick to any surface. So you could stick to a glass wall and it would stick just fine. Anyway, all sorts of cool applications for that. And we took that and another concept the co-blogger of mine on Selenian Boondocks, Kirk Sorensen, had come up with at Marshall Space Flight Center, was this idea of doing what he called boom rendezvous. And boom rendezvous is this idea that instead of a precision collision like you have right now for rendezvous and docking, you actually make a mechanical connection between 2 spacecraft using a long flexible boom. And so the spacecraft bodies are still several tens of meters apart when you make your initial mechanical connection. And so I took these 2 ideas and combined them. So you, on the one hand, have a sticky pad that sticks to anything. You have a long boom that allows your spacecraft to still be safely apart when you make the connection. And it enables all sorts of interesting applications.